Now let us consider other rules of differentiation other than the power rule. So we have y equal uv, that's the product rule. So this is multiplying this where u and v are functions of x. Then dy dx is given by hold v and differentiate u with respect to x plus hold u and differentiate v with respect to x. Then the quotient rule. So if we have u dividing by v this time, then the quotient rule says that hold v differentiate u with respect to x minus hold u differentiate v with respect to x all over v squared. Then the chain rule says that if y is a function of u and u is a function of x, then we have to find dy dx by differentiating y with respect to u and multiplying it by differentiating u with respect to x. And implicit differentiation is where f is a function of x and y equal constant. Then we cannot express explicitly y in terms of x easily. So in that case, we differentiate implicitly. So let's take some examples. So we have this over here. We are supposed to find the gradient of x y squared plus x squared y equal 4xy at the point 1, 3. So we know that the gradient is given by dy dx. So this is the product, this is a product, this is another product, and we can use implicit differentiation over here. So you know this is given by differentiating this one term by term. So we hold x and differentiate y squared, so we are going to get x. Then we differentiate y squared to get 2y. Then we have to indicate that we are not differentiating y, but we are differentiating x. So we are differentiating y with respect to x. Now, so that is the first part. Now we hold the y squared and differentiate the x. We are going to get y squared. We differentiate x, you get 1. Now we come to the second term. So we differentiate, we hold x squared and differentiate y to get dy dx. Then again we hold y and differentiate x squared to get 2x. Now we come to the right hand side. So we hold 4x and differentiate y, you are going to get 4x differentiate y, you get dy dx. And this time we add it to holding y and differentiating, holding 4x and differentiating. Okay, this time we hold y and differentiate 4x, so we are going to get y times differentiate 4x, we get 4. So now we have 2xy here, then we have x squared here, then we have 4x here. So we group the terms or factor the terms with dy dx on one side. We are going to get 2xy, then plus x squared, then minus 4x, minus 4x, then we have dy dx over there, dy dx is equal to, then we group all these ones to at one side. So we have 4y over here, so 4y, then we have minus 4y minus y squared, then minus 2xy, So you can make dy dx the subject to obtain dy dx divide the x to be equal to 4y 4y minus y squared minus 2xy all over 2xy plus y squared plus x squared rather plus x squared, then minus 4x. So we now sub in the values. So we have 4y, so 4 times y is 3. Sub in the point over here, y is 3 and x is equal to 1. So we sub in the point, then we have minus y squared, so minus 3 squared minus 3 squared, then we have minus 2 times x, which is 1, and times 3 all over, then we have 2 times 3, 2 times 1 times 3, then minus, that is plus 1 squared minus 4 times 1 minus 4 times 1. So if we simplify all this, we are going to get negative 1 as the result. Let's take another example over here. If x minus y squared is equal to 3xy plus 1, find the gradient at a point 1, 0. So the same thing applies over here. So we differentiate implicitly, but before that, let's expand the left hand side. So this is going to give us x squared minus 2xy plus y squared is equal to 3xy plus 1. So we have x squared plus y squared plus y squared is equal to 5xy plus 1. Now differentiating implicitly, we are going to get 2x. If we differentiate x squared with respect to x, we get 2x. Then if we differentiate y squared with respect to x, we get 2y dy dx. Then if we differentiate this one with respect to x, we are going to get, so we hold 5x and differentiate y, so 5x dy dx. We differentiate y, we get dy dx. Then we now hold y and differentiate 5x, so y into bracket differentiate 5x, we get 5. Then if we differentiate 1, we get 0. Now we group like terms over here, so we have dy dx here, so we are going to get 2y minus 5x dy dx, 2y minus 5x dy dx is equal to, this is 5y minus 2x, 5y minus 2x. So our dy dx now, so dy dx now is equal to 5y minus 2x, 5y minus 2x over negative into bracket okay, over 2y over 2y minus 5x over 2y minus 5x. So we sub in the values for 1 and 0, so if 0 for y and 1 for x, we are going to get 5 times 0, 5 into 0, minus 2 into 1, all over 2 into 0, 2 into 0, 2 into 0, minus 5 into 1. So this will simplify to negative 2 over negative 5, which is 2 over 5. So the gradient is 2 over 5. The gradient at this point is 2 over 5. Now let's look at this one. We're differentiating with respect to x over here. So we apply the product rule again. So we hold one and differentiate the other. So we have x minus 3, x minus 3, then differentiate this. We are going to get 2x. If you differentiate x squared, we get 2x. If you differentiate 5, we get 0. Then plus, this time we hold x squared plus 5, hold x squared plus 5, and differentiate x minus 3. So differentiate x minus 3, you get 1, differentiate 3, you get 0. So plus 0. So our dy dx now, our dy dx now is equal to, so dy dx is equal to this, and it is now equal to, this one is 2x squared minus 6x, 2x squared minus 6x, then plus x squared plus 5, plus x squared plus 5. So we simplify this to obtain 3x squared minus 6x plus 5.